AWARE, innovative hybrid MBR system to promote water reuse. The AWARE project aims at promoting the use of reclaimed water through the demonstration of the technical, economic and environmental viability of innovative technologies and treatment schemes. The AWARE project tackles key issues regarding the production, demand and distribution of reclaimed water. The demonstrative actions of the AWARE project take place in the water reclamation plant of Baix Llobregat in Barcelona. This water reclamation plant represents an outstanding example of water reclamation facility, which is a key piece for the sustainability and management of the urban water cycle, especially in water scarcity periods. Baix Llobregat water reclamation plant produces two different water qualities. The basic reclamation, which produces over 300,000 cubic meters per day of reclaimed water with the quality standards set by existing legislation for agricultural, industrial, municipal and environmental use. The advanced water reclamation produces 15,000 cubic meters per day of low salinity effluent by means of a combined ultrafiltration and reverse osmosis treatment. The water produced in the advanced reclamation is distributed along the coastline and injected into the aquifer as a seawater intrusion barrier. The conventional water reclamation treatments guarantee water quality for reuse for the different parameters established by the existing legislation. However, they haven't been specifically designed for the removal of priority and emerging pollutants, which have been pointed out by the Water Framework Directive of the European Commission and the scientific community respectively as chemical substances with negative effects on aquatic ecosystems. The AWARE project evaluates the feasibility of an innovative water reclamation scheme focused on the removal of priority pollutants and contaminants of emerging concern. The first part of the scheme, which is alternative to the basic reclamation scheme, is based on a membrane bioreactor. In membrane bioreactors, instead of applying the reclamation treatment to the effluent of the secondary clarifiers, biological degradation and treated effluent separation are integrated in a single step using ultrafiltration membranes. The second part of the scheme involves capillary nanofiltration membranes and is conceived as an alternative to the advanced reclamation, ultrafiltration and reverse osmosis processes. Nanofiltration capillary membranes remove dissolved organic matter, obtaining high-quality effluent. In comparison with reverse osmosis, they present lower energy demands and no brines are generated. In the AWARE project, different powdered activated carbon dosing strategies have been tested with the objective of enhancing the removal of priority and emerging pollutants and improving the performance of the membranes so as to reduce associated operational costs. The membrane bioreactor and capillary nanofiltration have been installed and operated in the Baix Llobregat water reclamation plant in order to validate the technical feasibility of the treatment scheme proposed in the LIFE AWARE project. The MBR and nanofiltration prototypes have been optimized by Cetaqua, coordinating beneficiary of the AWARE project during a period of almost 2 years.
The results obtained have enabled to conduct a technical, economic and environmental assessment of the technologies proposed in the AWARE project against the basic and advanced water reclamation plants of Baix Llobregat, and to identify which treatment schemes present a higher feasibility for the removal of priority pollutants and contaminants of emerging concern.
Within LIFE AWARE project, UNEC, the National Laboratory of Civil Engineering of Portugal, brings its knowledge of activated carbon adsorption and of hybrid processes combining adsorption and membrane technology for controlling organic pollutants. Our role in the project was First, to perform a selection of the appropriate powder activated carbon for removing emergent pollutants, and then to assess at lab scale different PAC-NF configurations to be implemented for demonstration at pilot scale. Furthermore, we provided technical assistance to the prototype's operation, namely by assessing the degree of saturation of the activated carbon used in the pilots.
Aigües de Barcelona, Empresa Metropolitana de Gestió del Cicle Integral del Agua, with a vast experience in the management, operation and water quality control of wastewater treatment and reclamation plants, has conducted several tasks.
The MBR and the nanofiltration demonstration plants have been designed and constructed with a high degree of automation and instrumentation, being able to operate continuously and with scenarios of high variability in water quality, which the real treatment plants have to face.
In addition, Aigües de Barcelona has also conducted an exhaustive analytical plan in both the AWARE prototypes and in the water reclamation plant of Baix Llobregat. This plan included the analyses of the parameters established in the Spanish Royal Decree for Water Reuse 1620-2007, as well as metals, microbiological parameters and organic micropollutants. The experience of Aigües de Barcelona in the management of distribution networks has also been applied to identify the factors that have the greater influence on the development of biofilms in distribution networks of reclaimed water. A distribution network prototype to simulate the operational conditions of a distribution network has been designed, constructed and operated with reclaimed water from the basic reclamation system of Baix Llobregat. The results obtained will contribute to defined management strategies in order to guarantee water quality at the point of use. The hybrid systems proposed in the AWARE project have shown to be technically feasible and a competitive alternative to existing water reclamation systems. The combination of activated carbon with membrane bioreactors and nanofiltration technologies presents significant advantages in comparison to the water reclamation systems implemented nowadays. Reduction of 50% of the treatment footprint. Complete removal of reject streams generated during the reverse osmosis process. Improvement in water quality in terms of solids and turbidity. The use of activated carbon in the hybrid systems enables removal efficiency of 70 to 90% of priority and emerging pollutants that are persistent in the conventional treatment. AWARE, water reclamation for the sustainable management of the urban water cycle.